Okay, so example 3, we're just continuing with section 6.3. So we want to prove 1 minus cos x over sine x. What's in the middle? Is that an equals? I have mine scribbled out. Sine x over 1 plus cos x. Okay, so we need to figure out what we should do first here. And my thoughts are I don't like that 1 plus cos x in the bottom. So I'm probably going to multiply by the conjugate. Do we remember what that is? The conjugate just means you multiply by the exact same thing but the opposite sign in the top and in the bottom. Okay, so then in the top we would have sine multiplying to 1 minus cos x. And in the bottom, we would FOIL this. And when we FOIL it, we get 1 times 1 is 1. 1 times minus cos is minus cos x. Then we get plus cos x. Whoops. And then we get a positive cos squared x. Okay, so a minus cos x and a plus cos x can cross off. And we would end up with nothing. We didn't do anything in the top, so same. And then we have a 1 plus cos x squared, or cos squared x. What is that? Does anybody remember? 1 plus cos squared x is the same thing as what? And we use this one all the time. Remember the Pythagorean identity? This one? Oh, sorry, is that supposed to be a minus sign? Yeah. This isn't a plus. I messed it up. It's a negative sign. So what is 1 minus cos squared x? If we were to subtract cos squared over here, cos squared, oh, that looks horrible, sorry. Sine squared is equal to 1 minus cos squared. All we did was manipulate the Pythagorean identity. Okay? And I notice when I've done these all the time, it seems to go back to the Pythagorean identity a lot. You use that one a lot, and you're going to change it to be sine squared or cos squared. So now instead of having 1 minus cos squared in the bottom, we'll just replace it with sine squared. Okay, so now we have a sine in the top and 1 in the bottom. Well, we had 2 in the bottom, so now we'll just have 1. We'll get rid of that squared. And so we'll actually just end up with 1 minus cos x over sine x, because we got rid of the squared. And that's what our other side was, 1 minus cos x over sine x. So we proved it. And the last example, example 4, says prove the identity. So we're going to try to change that super complicated side. We're going to end up changing both of them a little bit here. Let's look at this easy side to start with. What is cot? What can we switch that to? Yeah, cos over sine. And then we could switch cosecant into what? What's its reciprocal, or the opposite? 1 over sine, yep. Okay, so now they both have the bottom of sine, so we can just write one common bottom, and then we can write them together in the top, like that. Okay, so all I did was put the common bottom together. Okay, so that's this side. Now we have this complicated side over here. And as soon as I see this cos 2x, I think of the double angle identity. So what can I switch my cos 2x to? And remember, for cos there's always 3 options. So I probably want to switch it just to a cos option. So what's the cos double angle identity? it is 2 cos squared x minus 1. Okay, so all I did was replace this piece with 2 cos squared x minus 1, and then we still have minus cos x all over sine 2x plus sine x. Okay, so if I rearranged, if I rearranged this just up here, so I didn't do anything, I'm just going to put this minus cos x minus 1. What does this look like if you weren't really focusing on the coses? Yeah, it's a polynomial that's probably can be factored, right? Like if those were x's, we'd have like 2x squared minus x minus 1. Okay, so we would be able to do decomp with that or something, right? Okay, so when I factored those, so you could either do decomp or this one's fairly simple if you're thinking of just x's. If we were factoring it, its factors would be 2 cos x plus 1 and cos x minus 1. Okay, so that is it factored out. And then if you notice in the bottom of this one, we have, did I write the bottom wrong? Oh, we should replace that sine 2x in the bottom, because that's a double angle identity. So if we were replacing the sine 2x, we would replace it with the only option, which is 2 sine x cos x. And then we'd still have plus sine x in the bottom. Okay, so all we did was replace our sine 2x with the double angle identity. And that's a C. Okay, so now I'm just going to leave the top for a second because it's already factored. And I'm going to look at the bottom because there's a sign here and a sign here. So I'm going to factor the signs out. So that means I'm going to put them on the outside, like divide out by sine on both pieces. So then that would leave me with a 2 cos x plus 1 because I divided by sine x here and by sine x here. Sine divided by sine is 1. Okay, now you'll notice we have a 2 cos x plus 1 on the top and 1 on the bottom. So we can cross those guys off. So I'm going to cross him with him. And that leaves us with a cos x minus 1 with a sine x on the bottom. And that's what we had on this side. So we proved it.